Hi, Chance. I'm still at my conference and I'll be here all day tomorrow, so I won't be able to meet with you. But I saw that you wanted to go through some of the unresolved comments in your paper. And here I need to cite a source for parallax measurements on your star. So if you go to the Vizier catalog, this is how we find that information. And that's on the Canvas page as well, a handout on how to do that. Here is the Vizier catalog, and the first screen says find catalogs. The most recent one is Gaia, so I337 I/337/Gaia is the one you want to get. And then your position is the precise position from that data file that Dr. Mason sent you about your stars. So that's 091422.79524111.8. That's also from this WDS page on Stelladopy, gives the precise position of your star system. So you click go here, and it will actually, I think I clicked go too soon. No, it found it. It went to the Gaia catalog here, and it displays the first star that it finds. The closest one to your target is 0.2 arc minutes away. But I think that might be your primary, because if you look at Aladdin, the two stars are slightly off center, and I got to that by clicking on the Start Aladdin Light button. So I think these first two might be your stars. Looking closely at these, they have a parallax of 0.158 arc seconds. The units here, parallax, PLX, are in milli arc seconds, so that's why I put the decimal point 3 spots back. So they're 0.15896 arc seconds. And so to find how far away that is in parsecs, you just use a calculator, and as you recall, you divide 1 by 0.158 or 0.15892 or what have you. So that gives a distance of 6.33 parsecs for this system. Stelladopy says it is 5.81 parsecs away, and I would trust Gaia much more because that's more recent. It came out in the last few months and the measurements are more accurate. Where did this data come from, though, that's in Stelladopy? I'm guessing it came from the Hipparcos catalog. So to find that, it's I311, I think, HIP2. That's the most recent Hipparcos catalog. And we'll look in that catalog and see, again, this is the position, your precise position, and we'll click submit. And we will find, looks like only 2 stars were measured. If you start Aladdin Light, I think those were your stars, because the little red boxes that signify the stars that are in the image are a little bit offset from your stars. So I think this first one is your primary, even though it says it's about 1/5 of an arc minute away from your star's position. And then this second one, which is half an arc minute, or 30 arc seconds away from the position, is your secondary. I think those are the 2 stars in the image. It looks pretty clear from the Aladdin Light screenshot. The parallax here is listed as 172 milliarc seconds and 156 milliarc seconds. So I think the 172, if you do that on the calculator, pull up that calculator, clear that, and go 1 divided by 0.172, because the 172 milliarc seconds, that gives you your 5.8. So I think that's where the 5.81 comes from in the Washington Double Star Catalog. I think that they took the parallax data from Hipparcos and calculated a distance from that. And I would use, instead of this 5.81 parsecs, I would use the more accurate Gaia information that we just looked at. One other thing that I noticed is that the proper motion here is listed as minus 153, minus 155, and minus 56, minus 66. Strong evidence that the stars are gravitationally bound because they have common proper motion. But here, the proper motion in right ascension and declination is a full order of magnitude larger than that. So the PM-RA and PM-DEC is a factor of 10 bigger than it is listed. So these stars are moving fast. That might account for why they look off-center in the image. Let's see what Gaia says about their proper motion, or at least the proper motion of the primary, since that's all that Gaia had was the primary. So go back to Gaia and find it again. Oh, whoops, Gaia, what was it? 337, 37 Gaia. Go back to Gaia again. And again, put in your precise position, click submit, and I think it had proper motion on only one of the stars, probably the primary, but again, it was that factor of 10 bigger than is listed here in the catalog. So given that Gaia and Hipparcos agree, I would say that the proper motion values here might be off by a factor of 10. You should do some analysis of the proper motion of these stars. They seem to have common proper motion, meaning that they're moving together through space, and that's strong evidence for the gravitational binding. I mean, you guys have an arc in the motion of your secondary relative to the primary, which is also strongly suggestive of an orbital solution. But proper motion shouldn't be neglected. So definitely say something about that, about the proper motion of these stars being similar, and cite the values from Vizier. Cite the ones from Gaia or Hipparcos over the ones that you find in Stelladopy, because Stelladopy is a search engine to the Washington Double Star Catalog, and Gaia is the most up-to-date space telescope. Hipparcos is, I think, probably where the values came from in the WDS, but it seems like there's this factor of 10 discrepancy that both Hipparcos and Gaia agree on. In any case, it seems pretty clear that the value in Stelladopy for parallax did come from Hipparcos, but we want to use the one for Gaia from Gaia since it's more recent and more accurate in reporting the distance to your system. So I hope that helps, and I'm sorry I won't be able to meet with you tomorrow, but hopefully that'll give you enough direction to make the necessary changes. Thanks. Bye.